Most teams trying to build AI tend to hit the same wall. They prompt, they tweak, they test, but they end up getting more frustrated the more they use it and start saying that AI isn't good at coding or AI make too many mistakes. And it's not their fault. It's because almost no one teaches the full system behind effective AI development. And this is something I've learned through trial and errors by building way over 30 apps with AI. And in this video, I'm going to show you the exact 4-pillar stack I use to ship AI features fast. I'm talking building apps in a weekend or even in a day, without reprompting 10 times, without guessing why things fail, and you'll learn how PRDs, prompt engineering, context engineering, and memory engineering all fit together, and why skipping even one quietly sabotage every AI task you ship. Because if you're not building on these 4 pillars, well, unfortunately, that leads to the same loop: over expectation, under delivery, and total disappointment. So by the end of this video, you won't make those mistakes, and I'll teach you everything you need to break the loop. There are 4 pillars of AI native app development. You have the PRD, which is what success look like to human. You have memory engineering, which is what the model can recall later. And you have context engineering, which is what the model needs to see right now. And then you have prompt engineering, which is how you tell the model to act. So these are the 4 pillars of AI development. And another way to think about them are PRD is what matters, memory engineering is what to save, context engineering is what to inject, and prompt engineering is what to do. We're going to start with PRD. So how do you create a product requirement document? So this is a document that you usually have when you're doing an app development project. This is something that is pretty standard in app development and usually includes things such as problem statement, objective, success metrics, user stories, the scope, the functional requirement, any UI or UX guideline, the technical stack notes, some dependency, open question and risk, and often the milestones and timeline. Most PRDs define what to build, but when I'm writing a PRD for AI development, I use PRD to define how to build with AI. So I explicitly include some additional sections such as page path, so that I have a comprehensive breakdown of every single pages that will be generated, API endpoint, which is sometimes included and sometimes not explicitly. So I always make sure to include it explicitly. You also have the complete user journey flow that I like to include so that the AI know exactly what's the journey of the target user when using the product. And also I like to include the UI UX references. So any references that are visual or written that show exactly how the app is going to be functioning. And I like to include a complete data structure so that the AI has a good understanding of what's going to be the data structure. And from that, it's able to infer input field or how things are going to work for that user. And I also like sometimes to include sometimes I will ask the AI to include any edge cases that he might have discovered or found that I might not have mentioned. And also there's the integration references. So if you have any integration with third-party API, you want to make sure to include these in your PRD because you're going to use that PRD to generate the foundation for the application. Now, on the list of what not to include, something that I don't find very relevant in when you're building with AI is a timeline. So usually I will ask it to remove the timeline, and sometimes I might keep the milestone or remove it because milestone in a PRD are usually tied to a timeline. So that might not be as relevant for building with AI. And also you can generate these later if you're using a product like Taskmaster or if you're just asking the AI to generate that for you. So once you have the PRD, you can feed that to your coding IDE, Claude Code or Cursor. And with that, it'll have a good understanding of what it needs to do. And usually the next step after that is to generate task. There's actually an entire workflow that happens between PRD and getting to the first version of your product. I like to have a step in between, which I will explain in a different video, where I actually generate a fully working prototype before I actually use the tool inside of a tool like Cursor. So in this video, I'm just sharing the 4 pillars, but there are some steps that you can do in between if you want to. And I'll make a separate video where I explain my personal workflow, but technically you only need what I'll cover in this video in order to have a very effective AI development workflow. So the next thing is prompt engineering. So prompt engineering is how you tell the model to act. And oftentimes people have really bad prompt and they are surprised with the result. An example of a bad prompt can be something such as, can you add email login to my app? It should be secure and fast. return the code you change. You might wonder what is wrong with a prompt like this, because oftentimes people will feature a bad prompt, but it's hard to understand why these prompts are specifically wrong. So I wanted to make sure to cover that so that you get a really good foundation in understanding why this prompt is bad, so that you can actually write better prompt. Some of the things that are lacking in this prompt is that there is no role or stacks, right? So the model might pick the wrong framework. So if you wanted to build something with Next.js, it might decide to use something else. It could use Rails, it could use Python. Also, you haven't specified the framework. So you technically letting the AI guess what framework you want to use. Secondly, there's no scope. So it could edit any files, right? So where do you want this to happen? For example, is this email login going to interfere with Superbase? Or do you want it to add a new authentication framework? So all of this is missing from that prompt. And so you're letting the AI guess any of these details. So the next thing that is missing is the context, right? So the model can't see the current code. So you're not really telling it in what code to look at. Even if it's able to see the current code, you're not pointing into what areas of the code you need to focus on in order to implement that. So you're making something very general and just letting it decide where to put that. So if you have an app that is like brand new and you want the AI to figure things out for you, you can do that to a certain extent, but you still need to have the role, the stack, the scope, the context, and also you also want to have a way to plan how the AI is going to test that it's built the right feature. So with zero tests here, so you have zero reasoning and zero way to verify that what the AI is going to build is actually going to work as expected. The only way for you to verify when you do something like this is to actually run the app and try it yourself. And there's a way for you that are very simple to just tell the AI to test it on its own to make sure that once it's implemented the feature, that it's working exactly as you will expect. Greg Brockman, one of the co-founders of OpenAI, once shared on his X account the anatomy of an O1 prompt, so the anatomy of a reasoning prompt. This is a very effective guide to figure out how you want to break down your prompt. But what I've realized over time is that that doesn't really apply well to Cursor, because the way this is written is mostly for research. If you wanted to do something like writing a blog for you or figuring out how to do something for you that is not related to coding, because there's no code-oriented guardrails. So this is not effective for Cursor. So as you can see, there's no roles. So without a stack definition, the agent may suggest wrong framework or style again, and then there's no scope. So there's a risk of the agent touching unrelated files or making schema changes you didn't intend. There's also no memory leverage. We're going to talk about memory in this video, and this is a very important aspect of the 4-pillar. So it doesn't leverage any memory, any information, any context that will make it even better at actually generating the code for you. Also, there's unnecessary return format. So Cursor by default return code diff output. So when you're asking it to return this kind of format, like the one specified in this prompt, this is not helpful. So for example, if you were to say output JSON, this is not really helpful unless you specifically wanted to output a JSON to use it somewhere, because Cursor is already going to generate some file for you. So you don't need to add that. This is just unnecessary token. You're just wasting your token by adding things like this. So what I did instead is I recreated a new anatomy of a prompt, but I created specifically for Cursor. So I call this the anatomy of a Cursor prompt. And as you can see, this is code-oriented. There's code-oriented guardrail. There's role, there's constraint, there's a precise file context, there's a step plan, there's a memory recall, and there's a verification rule. So we're going to zoom in. So as you can see here, we have you are a senior Next.js developer, where we're defining the role and the stack. So we could have said, for example, you are a front-end developer, and the stack is Next.js, Tailwind CSS, and so on. So this is where you want to add the stack. So you want to start with that. Next, you want to set up the goal. So our goal here is pretty simple. I went with a one-liner here, but sometimes you might have multi-line prompts. And in this example, I'm saying add email password off using Superbase off. But that could have been something a little bit longer if I wanted to add a more complex feature. So sometimes it's even multiple paragraphs. Sometimes when I'm doing this, because I want to be very specific. Also, you have the scope constraint, where you say something such as only edit files inside of app controller or app services, no DB schema changes. Sometimes you might want to specify what you want the AI to modify, especially if you have a big app where the AI might be confused or might make assumption by adding this kind of scope and constraint, you're ensuring that the AI doesn't unintentionally modify files or areas of files that it's not supposed to. So you can, inside an app like Cursor, you can literally just drag and drop the files that you want it to have its focus on. If you know, for example, specifically in what file the edit will happen, you can just add that file as context. This is what you're seeing here on the next line, where we're adding the file and the context where we want the AI to, look at and maybe make the change. The next, you have the plan. Luckily, Cursor has added this thing called to-dos. So you can say something such as make a clear to-do list before you code and include each major step you plan to take. Alternatively, if you know exactly what steps you want the AI to follow, you can literally write down those steps. Like, I like to use number lists. You can use an unordered list, or you can use literally step 1 to G, step 2, and just have a lot of clarity into how you want the AI to implement the feature and following what step. Does it need to build one part of the component first before building the next part? So you want to have some clarity into that ordering steps. And then next, you have the memory recall. So this is when you're having a persistent memory. I'm going to explain you in a little bit how I go about doing this. So I like to have a memory doc folder where I have the persistent memory that I want the AI to remember so that it can recall later. Cursor has its own memory, but it works a little bit differently. Than how I'm currently using memory. And I'm going to show you exactly how you can use memory docs in order to give it even more power and context to your AI engineers when you're coding with it. And finally, you want to have a verification. So the verification can be something as simple as saying, test this with a curl request, test this with a unit test. You're just giving instruction on how the AI is actually going to verify that the work that it has implemented is working as expected. And this is really cool because instead of writing a prompt, having the AI generate the code, and then you coming back and asking it to verify it by writing another prompt, what it's doing here is using a verification scope inside of this prompt as a way for it to verify that what it's implementing is working as expected. You can even think about it like an acceptance criteria. So once you build the feature, you always make sure that it is following the verification step, making sure that it's not doing something outside of the expectation of that verification, which is super powerful when you're building with AI. By the way, I have a community called AI Founders Club where I'm sharing courses on how to do, prompt, how to code with AI, and there's a course called Prompt Engineering Anatomy. So if you're curious about taking that full course where I go deeper into how I write prompt using AI, make sure to join the community, and you get access to members perk with Firecrawl, Composio, 8nodes, Mastra, and Geeklands. So make sure to check this out. All right, so next, I want to talk about context engineering. So I recently found this tweet by the founder of Shopify, Toby. He said, I really like the term context engineering over prompt engineering, and he described the core skill better, the art of providing all the context for the task to be plausibly solvable by the LLM. So when I saw this thing, it really got my attention because what I noticed here is that you can't really remove prompt engineering once you have context engineering. You kind of need both. And this is why I went and I wrote this response, because actually I agree with Eyal Toledano. So this is the creator of Taskmaster. We also mentioned that we actually need both. And I responded by saying that prompt engineering helps the model understand what you want. Direction plus intent. Context engineering gives it what it needs to respond well. So the best context engineering feeds it exactly what humans rely on to reason. So knowledge, memory, reasoning steps, and visual perception. So that was my answer. And then I think this is a good intro to what context engineering actually is. Because context engineering is how you're adding enough context for the AI not to make any guesses. And you're adding it at the time when you are about to submit that prompt. So this is why you don't just want to store information. When you're providing context engineering, you also want to make sure it gets retrieved at the right time. And that's where rules comes in. Because rules are the glue between memory and context. But before we get into diving into rules, I want to explain what are memory and what's memory engineering as a whole. So memory engineering is what the model can recall later. So it's very different than context engineering. So it's not the same thing. Context engineering give you context about, about the application, it's what you inject into the model for this specific task, while memory engineering is what you save and that you want to have the ability to inject later. So an agent without a memory will make something up. It will just guess because it will have the context of what you're talking about. So using the memory to make sure that the agent can actually use a reference and not make guesses about things. So I personally like to have memory for my architecture, diagrams, for how feature works, and whenever I want to make sure that the AI has a good understanding of that context, I will inject that inside of the prompt to make sure that it has the right context. So when you fail to load the right memory into the context, that lead to hallucination because the model doesn't know exactly how to do things, and it just makes assumption or guesses because the knowledge that it needs is not part of its training. So context engineering is like choosing the right slice, and memory engineering is like making sure the right slice exists. So you are doing it preemptively. So you are creating all of the information that you would like to reference later. And then once you are about to submit the prompt, you choose what memory you want to provide inside of the context to make sure that the prompt has all the information that it needs for the AI to understand how to achieve the task. So this is why memory engineering is what the model can recall later. So anything we want the model or future AI engineer to reference again, that's what fits into the umbrella of memory engineering. So if you want consistent code and give the model something to be consistent with, then you need to have memory. Memory engineering is also different from cursor memory. Memory engineering is more like long-term created knowledge base, while cursor memory is how cursor retain project knowledge base. So memory helps the model not having to solve the same problem twice because it has that context. For example, when I have my memory, I like to have bug fixes that I've already fixed so that the AI doesn't try to fix the same bugs. Because I've run into a situation where the AI fixes a bug, then reintroduce that same bug again, and then goes into that same loop of fixing that bug, not remembering how it fixed it in the first place. This is when memory is extremely powerful because you can have the full documentation of that bug fix and making sure that the AI doesn't redo the same mistake. And when the AI is confused and, for example, enters the bugs or make the same mistake, you can just feed the context of that memory about the bug fix and making sure that it doesn't repeat that. So cursor memory, because it's retained the project knowledge, it's like the model's map of your repo. So cursor will try to remember what you said in chat, try to remember things long-term about how you like things to be done while chatting with it, and it will feed that inside of the context at certain time when needed. And because memory engineering is not automatic, it's more of a manual inclusion that you add inside of your prompt. This is why I like to say that it is the discipline of deciding what the model should remember and how to feed it back. Because this is not something that you do automatically. So you have the discipline of creating your memory. So whenever you fix a bug, you're asking the AI to generate a document for this bug inside of your memory doc. Whenever you're doing the architecture, you're generating the file for it so that you can reference it later. So you're building that discipline, and that discipline will help you later on to make sure that whenever you need to feed the right context to the AI, you have that available. So memory engineering is like the model external persistent brain. But so it's like the model external persistent brain. So how do you build that external brain? This is what I'm about to show you. I'm going to show you exactly how I break it down. What I like to do is creating a memory docs folder inside of my application. And inside of it, I create subfolders and files. I'll create a file called architecture where I add all high-level system docs and diagram. I create a file called fixed guides where I add post-mortem resolution. So after I've tackled a bug and finally the AI was able to find a solution to that bug, I would ask it to generate a fixed guide so that it knows exactly how to fix that same bugs in the future. And also so that it has context about how the bugs happen in the first place and how to avoid it to make sure that we're not repeating the same thing over and over again. And you can imagine that this can be very powerful. If you're always facing the same issues with AI and you have a documentation about all of your issues, you're not facing that same issue twice. You can just feed that guide. And because cursor index most of the content that you're feeding it inside of a vector database, it kind of has the context of those data as well, even when you're not feeding it to it right away. But when you want to be specific and making sure that this is part of the context, you can just grab the file and feed it. Then I also have an open issues folder where I add anything that is still broken or needs work. So if I'm currently facing a bug and haven't figured out a way to fix it, I will ask Cursor to document all the assumptions that we have about that issue and everything that has worked and everything that hasn't worked. So I wanted to make sure that it has all the full documentation of what we have validated and invalidated about that issue. And this approach allows it to not retest the same assumption, but be aware of what was already tested, what was already validated, and moving forward toward the resolution of that bug. So this practice has been extremely powerful in fixing very complex bugs with AI. So I make sure to always have that inside of my open issues. And once the issue is fixed, then I can move that inside of the fix guide. So now the good thing about this is that even if you have the issue inside of your fix guides and open issues, the information that they're storing are a little bit different, right? Because the open issues will have all the assumption, everything that was tested and not tested, while the fix guide will have the problem and the exact solution of fixing that specific issue. So you're getting really good context here, because if you're facing a similar issue, you can use an open issues and then the documentation that you have about the assumption to help the AI understand how to fix that issue that it seemed to be similar to the one that it faced in the past. Then also you have an audit folder, which contains anything like performances audit, cost audit, security reviews. So the way I've gone about using that is by, for example, whenever I want to improve the security in my app, I will ask AI to analyze the entire app and generate a security audit file that cover anything, any potential risk, insecurity that we have. So I have a complex audit of that security and what needs to be fixed. I will sometimes ask it to analyze the cost and of the application, so all the pricing and the cost, to make sure that we're not missing something or miscalculated something. I'm making sure it just double check, but obviously I have to make the calculation myself with my own math, but I make sure that it can double check some of the logics. Also, I will have it do a review of performance to make sure that we have a complete audit of optimization, what areas of the app need to be optimized, where there's room for optimization, where or even sometimes I will feed it some of the requests that were slow and make sure that you have a complete audit of all those requests from the log. So very powerful if you want to have a memory docs of a complex understanding of different aspects of your application. Another thing I like to have is a references folder. So this is where you add anything such as APIs, schema, checklists, feature description, anything that can help the AI understand a feature. If, for example, you are building the feature and you want to add more context, you can just add all of that in the reference. You can also add references to alternative resources, just like making sure that it's helpful for the AI to consume. Then I also like to have a progress.mg. So this is like a single running changelog. This is where you have a checklist. Usually I like to make it as a checklist where you have a little cube and the AI is able to check mark things that have been done and completed. For example, if I have an implementation plan where I have the full list, I will have all of the checklists of what's implemented inside of the implementation plan. And inside of the progress, I'll just document the change log. This is what we've done. This is what future AI engineer has to be aware of that has been done inside of the application. And sometimes it might have context of what we're currently working on, because it is updating it as we are coding. And I often have rules to automatically update those files. Then I have a features.mg, which is kind of like a breakdown that consolidates anything that was shipped, all the features that we have in the application, how they work. So this way, when I'm talking to AI and asking to modify a feature or do something in the feature, I can just feed that to give it context about like what's the feature about, how it works, what's the expected user journey. So for example, if I'm doing a redesign, super easy to feed that and have the AI have a good context of it. Because remember, it already has context of the code, but then you're giving it additional information in terms of how it should work. That covers memory docs and how to give memory and how to do memory engineering. And now I like to get back to rules, because rules are super important, because we talked about how memory is something that you want to inject later. So next we have rules, and then rules are things such as cursor rules or Windsurf rules or cloud rules. They are how you give guideline to AI on how to behave, essentially. But you don't just want to store information with memory. You want to make sure it gets retrieved at the right time. And this is where rules comes in. Because with rules, you can tell the AI exactly how to behave and when to inject different information that you have inside of the context. To just sum up what we just talked about, so we have memory engineering, which is what to save. We have context engineering, which is what to inject. And then we have prompt engineering, which is what to do. But then when do you retrieve that, right? And this is what I was saying. Rules is what allow you to actually retrieve the information and decide what to inject. So you can tell the AI exactly how to go about doing that. And actually, Cursor, for example, when you're looking at the rules in Cursor, you have the ability to select different options between always apply, apply intelligently, apply to specific file, or apply manually. And based on what you select here, the behavior of how Cursor handles rules will differ. If you pick the first one, it'll apply to every chat and command case session. If you pick the second one, apply intelligently, it will only apply when agent decide it's relevant based on description. So you have to make sure that the description that you have inside of the rule is helpful. And if you want to be applied manually, you will have to specifically mention these rules. So sometimes in your code base, you might have rules that you want to always apply, and you might have rules that you only need based on a specific context. Oftentimes, you might go with apply intelligently, let Cursor decide what's relevant, but sometimes some specific file might need to always apply those rules. So think about if, for example, you have database files that are managed for Superbase, you might want to make sure that any files that relate to Superbase use the Superbase rules. So this is kind of like what rules allow you to do. It allows you to also specify when you want that context to be injected. Since rules are essentially additional context that you can give in terms of when to inject the prompt, aren't rules essentially just context? And yes, they are. So rules are context engineering. So this is why it's not one of the pillars, but it's part of context engineering. So rules fit inside one of the main pillars that we have, which is context engineering. It's not its own thing. It's technically what to inject and when to inject it. So again, you don't just want to store information. You want to make sure it gets retrieved at the right time. And I keep repeating that because this is very important. Because when you create all of those files of the memory doc, sometimes you have the assumption that because you're using Cursor, the AI will just know that because it's there, it will know what to do with it. But no, you need to decide when to implement that. And you can do it very effectively with rules. I often do it manually, half manually and half with rules, where I will explain that if we're dealing with certain things, if we like, for example, generating a new feature, make sure to always check architecture.md. If, for example, we're dealing with bug fixes, check the bug fixes folder to make sure that we haven't resolved that issue already. So there's different ways that you can utilize rules to make sure that it gets injected at the right time. And then when I want to specifically mention it, this is when I will add this file specifically myself. But this is how rules bring memory and context together, because it is specifying how to inject the context that we had saved into the context that we currently have. So rules glue between memory and context. All right, so now we have our four pillars. So we have the PRD, which is what matters, what you want to build, how you want to build it. We have the memory engineering, which is what to save, what you want to call back later, inject later. We have context engineering, which is what to inject now. So that is part of the context of the prompt. And we have prompt engineering, which is telling the AI exactly what to do. So once you have all that, there's one more thing that you have to be aware of. And this is not a pillar, but this is something very important that you have to be aware of. And this is capacity control. And capacity control is part of the context window. So the context window is what the model can see right now. This is all of the context that that include all the limited space where the model can see your input, anything such as instruction, memory, all the injected files, some of the responses from the model. All of that is in the side of the context window. And the model has access to that context window right now. Think about it like the model's short-term memory. And then that context window has a certain capacity. And there's a problem when the context window is way too big. So the problem is that with ongoing chat, the context window fills up. So now the model doesn't really know what to do because now it's getting confused. So you want to maximize the use of your context windows, but not to the point where you're getting diminishing return, where it is too long. And this is why when you're using an IDE like Cursor, whenever you build a task or build a feature, you want to create a new chat to make sure that that context windows is reset and it's not like full of junk, unrelated context, unrelated memory. You want to make sure that what you have in memory at the time of execution is always what's relevant to the task at hand. So make sure to always create new chat in order to reset that memory. Because once it is full, then the clarity collapses. So you want to be very careful about it, because bad capacity control lead to very bad and expected result. For prompt engineering, the prompt engineering get buried under old instruction. Your context engineering includes irrelevant files from past tasks. Your memory engineering becomes noisy, and past summaries or fixes may override current needs. And the AI agent may get confused with all the goals still hanging in memory. So your capacity control is very important. So before you hit enter, ask yourself, did I give cursor just what it needs and nothing more? Inject only the file, diff, or logs directly relevant to the task, and start new chat after each task. And you'll make sure that anything you have inside of your context is always relevant to the task at hand, and that the AI doesn't get too confused about the tasks that they need to do. So this should cover all of the 4 pillars. I've been building a PRD and memory doc generator. This is a SaaS that I'm going to be releasing in the next couple of weeks. So if you guys want to get early access, make sure to join AI Founders Club and to get access to this application as soon as it is released. And this is on School. So if you go on School, search for AI Founders Club, and you get access to this application. So with that, you guys should now have a really good understanding of the 4 pillars of AI development. And with this knowledge, you should now be able to build applications more effectively with AI. And I've used all of this knowledge to build application in a day or application in a weekend. And then just by focusing on these 4 pillars, that's all I needed to build things effectively. And so if you feel like you're not getting what you need out of AI, make sure to double check that you have a good understanding of those 4 pillars, or reviewing how you're actually using that. I hope you guys enjoyed today's video. Thank you so much for watching, and I'll see you guys in the next one.